Welcome back to another video from Your IT Explained. In this video I've got a fairly complex lab set up in GNS3 where we're going to go through quite a few different components of route redistribution between various different protocols. So if you've been following along in the series so far, this is probably going to look a hell of a lot more complicated than what we've been going through previously. This is going to be the final lab for the route redistribution troubleshooting. So I've upped the ante a little bit here and made it a little bit more complicated than usual. So don't worry too much if you don't quite grasp everything that's going on. It's just the route redistribution that we're focusing on. But for example, some slight changes would be in EIGRP I've started to use named EIGRP instead of the classic like I have in the past. I've introduced inter-area OSPF routes, introduced RIP, a few different things to make it a little bit more complicated. So if you're still a bit confused about what's on screen, I suggest you just pause it and soak it in for a little bit to see what's actually running. Otherwise, I'll just give a quick run through and then get cracking straight away. So I've just got RIP between these devices, BGP, EIGRP down here, OSPF area 0 as a backbone area up to OSPF area 51 between router 5 to 7, and then just static routing from router 3 up to router 9 via router 8. Now every device is configured with IP addresses, the routing protocols, everything's good to go. The only thing that's not running is the actual redistribution between routes. So for example, on router 3 I should be able to ping router 7 right now, but router 7 could ping all the way through to router 3, but it won't be able to ping anything beyond that because there's no redistribution between OSPF to other protocols. I'll just confirm that for you so you can see what is running. And if I go to router 7 and just do a ping to, let's go the OSPF IP address on router 3, that'd be 20.0.0.3. Now the last octet always matches the number of the device, so we're doing 20.0.0.3. Success! But if I try to ping, let's say, the other side of router 3, the BGP IP address, so 20.87.43, ping 120.87.43.3. Now this one should fail, and I'll just end that and do a show IP route so you can see what is currently known on router 7. So router 7 just knows one intra-area route through OSPF, which is still an OSPF route because it starts with 20.0, and then there's regular OSPF route because it's in the same area, and then the connected routes. Alright, so without going into every single device, hopefully you can just trust that everything is configured the way I said it is. Just route redistribution is not yet configured. The only other thing that's missing from this diagram that I haven't really explained is that I am pointing a default route up from router 3 towards router 8. So if there's any address that's not known, then the devices should be going up to router 3 to then go up to router 8 and beyond. So to make this a little simple, let's start on router 2. Like router 3 is obviously going to have a lot of redistribution configured, but let's start off simple and start on router 2. So I'm going to console into router 2 here. Just quickly show you what is known on the device. Just what is connected on either side. It's running RIP and BGP. Now we want to configure mutual redistribution between both of these protocols. So I'll just set this up over here, and let's start by going to configure terminal, and let's redistribute into RIP first. So that's just router RIP. And now in here I'm going to just type redistribute like we always do, what are the options available? Same things as always, BGP, and then it just asks for the autonomous system number, 50. Alright, so now, if I go to router 1, check if that worked. No, it did not work. Now, why is that? Instant troubleshooting. It's because RIP, being one of the oldest distance vector routing protocols, does need the metric to be specified. So let's do that. Let's go metric, see what's available. Now, RIP is very old school. The metric it uses is just a simple hop count with a max of 16. So let's give it a metric of 1. So any BGP routes coming into RIP will have a hop count of 1. Now if we go back to router 1, refresh this, voila. We get the BGP route coming through. Now you might be asking yourself, why is it coming through as a /8, like 120.0.0/8, when it's actually this address here? And this is to do with RIP being so old, it is a classful routing protocol. But not to worry, with our specific situation here, it's still going to work for us. So if I try and ping 120.87, or actually this might not work just yet. If I ping that, good, excellent, it does work. So we can still ping it even though the network it's almost like a summary address, the way that it comes through because of the classful addressing. But if I go to router 3, if I just console in, let's see if it knows how to get to router 1. So I've just brought up the IP route on router 3. It's got a ton of addresses it already knows, but we're looking specifically for the 100.0.0 network. And it's not anywhere in here. Right, so router 3 does not know about it, and that is because back on router 2, we now need to redistribute the other way, remembering mutual redistribution. So we've done it one way, I want to do it the other way as well. So router, we're now redistributing into BGP. On this device, it's autonomous system 50. Now I've configured it to go into address family IPv4 unicast, and then redistribute. What are the options? Same as always, RIP. Okay, so now it's redistributing RIP into BGP. If I go back to router 3, let's refresh this. Sorry, I'll just clear that off, refresh this. All of a sudden, this comes through as a BGP route. Excellent. So that's as simple as it is for redistributing RIP into BGP. And that's done. So redistribution on router 2 is now done. It's going both ways between BGP and RIP. Now unfortunately, router 1 won't know how to get to any of the OSPF destinations or any of those static destinations or EIGRP because we have not redistributed those protocols on router 3 into BGP. Because once we do that, router 2 would then redistribute those into RIP. But because we haven't done that, router 1 only knows what it's currently configured from BGP. Okay, so we've got that little one out of the way. Now to tackle the big boy, router 3. We need to configure mutual redistribution between all these 4 protocols here. So I'm going to redistribute static, OSPF and EIGRP into BGP. Similarly, with OSPF, I'm going to redistribute static, BGP and EIGRP. EIGRP, I'm going to redistribute BGP, static and OSPF, right? So there's a lot to go into here. Let's just dive straight in. Router 3, sorry, I already have a console session open. Now that we've done the RIP configuration, I can just move this out of the way. for the time being at least. And I'll set this up just here. Alright. Oops. Conf C. And let's start by redistributing into BGP. Okay. Router, BGP, and this device, it's Autonomous System 100. Address family, IPv4, unicast, and redistribute. Now, what options do we have? Now, I'm just going to go through alphabetically on what we're redistributing, because we need to redistribute static routes, OSPF routes, and EIGRP routes. There is actually something else, 2 other things actually we want to redistribute, but we'll come back to those later. So, of these 3, what comes first? EIGRP. So let's do that first. Redistribute EIGRP. Now, I've named it on this device as EIGRP dash named or mode. Not sure. We'll come back to that. But it still has an autonomous system associated with it being 25. I'll quickly show you. So do show run, and we'll begin at EIGRP. Oops, sorry. Alright, so I've called it named mode. And then I've gone into address family IPv4 unicast, and here we specify that autonomous system 25. So it is still specified. Alright, so if I'm still, like where we are now, remembering I'm still inside of the BGP configuration, I want to, redistribute, choosing EIGRP, autonomous system 25. Now there are more options, but we'll just press enter and see what happens. So now we're redistributing EIGRP into BGP. We should, hopefully, on router 2, start to pick up the EIGRP routes if it's working correctly. So if I go to router 2 and do a show IP route, look at that. That's all it was required, nothing extra. We're picking up the EIGRP routes. So EIGRP is now being redistributed into BGP. But also recall, on router 2, we are redistributing BGP into RIP. So therefore, router 1 should know about the EIGRP routes, because EIGRP is being redistributed into BGP, and BGP is being redistributed into RIP. So if I go into router 1, let's have a look. Show IP route, and look at that. I didn't have to configure anything extra on router 2 because we already configured the redistribution from BGP into RIP, so it's picked up the redistribution from router 3 from EIGRP into BGP. Little complicated, maybe a little hard to wrap your head around, but I'm sure if you start playing around with this yourself in a lab, it'll click in no time at all. Alright, so back on router 3. We've redistributed only 1 protocol so far. So let's start cracking on a little bit faster. Next one alphabetically is OSPF. OSPF process 1. Now we've got these other options, but let's just do it like we normally do and do enter. Now we're not going to run into the issue that we had in the previous video. If you haven't seen it, check out the video of redistributing between OSPF and EIGRP. I believe it was that video that we covered this, where you need to specify match to match the internal and external type 1 and type 2 routes. But in this particular configuration, there are no external OSPF routes. There's only inter-area OSPF routes. But let's say off router 7, we had a static route, or we had a BGP, some other protocol, then we would have to, when we're doing this, specify a little bit more if we want to get all the routes through. So just as part of good practice, let's include that, as if we were configuring it that way. So now I'm going to do match, I'm going to do internal, and then external 1, external 2. So if you're not following along, just go back and watch that video, because we go through it in the other redistribution video. Alright, so now if I go to router 2, let's just confirm that it's picked up some new routes. And sure enough it has. It's picked up all of these. Excellent. So that's all that was required. Next one, redistribute, static. So I want to redistribute the static route, so we know, into BGP. So static. Now there are some other options I could put in, but I'm just going to leave it like that. Now I'll go back to router 2, see if it's picking up some more routes. And it has. It's picked up this one. But it's not picked up 10.0.1.0. Now I wonder why that is. And it's quite simple. If I go to router 3, we'll show you what the routing table looks like. Do show IP route. So we're looking for this 10.1, so 10.0.1.0 network. And 10.0.1.0 is right here. And if we look at the icon on the left, we can see it says C. It's a connected route. It's not static. It actually do have a static route specified in the config. And let me show you that as well. Show run. Oops, sorry. Begin at IP route. We can see I do not have an IP route for that specified. Sorry, I thought I did specify that, but perhaps I didn't because I knew that was unnecessary. Because the connection is directly connected, so you don't really need to specify a static route from router 3 to router 8 on this connection. You just specify the IP addresses and they'll talk together that way. You do, however, have to specify the next one as a static route, being the 10.0.0.0. Now, if you're a little bit eagle-eyed, you're probably picking up on something here, being the default route that I've specified. So I've specified that any traffic is just going up to router 8 from router 3 for any network that we don't know about. Anything that we don't have an actual route for in the table. So we'll have to come back to that in a second. But that is, so because we don't have that as an actual static route, the 10.0.1.0 network, that's why it's not going over into BGP and coming up on router 2. So to rectify that, what we have to do on this device is redistribute, and there's another option here. Connected. You can actually redistribute connected routes. So let's do that, press enter. Now if I go to router 2, refresh this. Now we've picked up this route here. Alright, so it's important to make sure that you're aware that this is also an option available to you to redistribute connected routes. Okay, now there is one other thing we just saw on router 3, which was the default static route. And if we go over to router 2, it does not have the default static route. It has not been redistributed into BGP. So this is a little trick that you do have to remember. When it comes to redistributing default static routes with particular protocols, there is extra steps involved. So BGP, what you have to do is specify a particular command, and it's not redistribute. So if I just do a question mark here, we'll see what we have available to us. We've got a few different commands that we can use, but the one that we want is this one here. So we'll start with that. So I'll start typing default information, and there's only one option, originate. It's not so intuitive, but if you put this in, now if we go to router 2, let's refresh the list, this comes through. So if you want to redistribute a default static route or a default route into BGP, you have to remember to use that command. Remembering we're specifying this within the address family IPv4 unicast within the BGP routing process. And that should be everything. So now router 2 will know, sorry, jumped a little bit too far. Router 2 and 1 should know all of these different addresses. Now the pings won't work even though they know about them, because the other devices don't know how to get back to router 1 and 2, because we haven't done the full mutual redistribution. But if I go to router 1, this is what we saw last time. I do show IP route to refresh it. We can see we're now picking up the so we've got firstly the default static route that's come through. We've got one of the other static routes. We've got a summary address for all of the OSPF routes. I've got the connected RIP routes. I've got the BGP route, and I've got the EIGRP route. So I should theoretically be able to reach from router 1 any other device now. It's just not going to return because the other devices don't yet know how to get back. Okay, so that's it for BGP. One protocol down. We now have, if I scroll this across so you can see a little bit easier, we now have 3 more to go. So there's a fair bit to this. Hopefully you're following along. If you're a little bit confused, take a break, pause the video, and come back at a later time. Otherwise, let's just crack straight into it. So next, let's do OSPF. I'm going to redistribute into OSPF. Let's start with the redistribute command, and I'll again just go through alphabetically. So we'll start with BGP. So redistribute BGP, what autonomous system? It's going to be 100, being the closest one on this device. There are some other options available to us, but I'll just press enter. Now if I go and just test on router 5, let's see if it's worked. So this is a general process I'm going to go through. As soon as I do it, we'll just check on the next device to see if it works or not, and if it doesn't, we troubleshoot. But on router 5, we have now instantly picked up this and this, so the RIP and BGP routes. So it's working, no more required. Excellent, that's what we like. Next, redistribute EIGRP. Now, connected as well is also available. Let's just do it just so that we're all happy with everything that's been configured. So we'll do that one, and now we'll do the EIGRP. Autonomous system 25, enter. So now if I go to router, so I'll move this across a little bit so you can see that's router 5. I'll refresh this. Now up here we didn't have the 10 network. We now do have that 10 network because I redistributed connected, but we don't have 10.0.0.0 because I haven't redistributed the static routes in yet, or the default route. But we have now also picked up the EIGRP. So excellent, nothing more required there. Now redistribute, what's remaining? Keep going down the list. Not OSPF, we're not redistributing into ourselves. Now RIP is an option here, but we don't need to because that's already included in BGP. So don't confuse yourself by adding in things you don't need to. Last one is going to be static. There's a few options, but we'll just leave it like that. Now if I go to router 5 and refresh, hopefully we'll now see up here the 10.0.0.0 network, like actually as an OSPF external type 2 route. So let's go, sorry, here, refresh, and there we have it. It comes through. Excellent. And that's it, done for OSPF. Nice and simple. Except, is it? If I go here, where is that default route? It's the same deal as BGP when it comes to OSPF. We still have to do that redistribution of the default route, and thankfully it's pretty much the exact same method as BGP. So if I do a question mark here, we'll see that we already have this default information command available to us. So default TAC information, what's the options? Just originate, done. And now if I go to router 5, refresh this list, we now see we're picking up that default route. Excellent. Okay. Now, let's go into redistributing into EIGRP. So router EIGRP 25, this is what you'd normally do if you're doing static, but remembering this is not how I defined it on this device. I did named mode. And now this is where it's going to get a little different to what I've done in the previous videos with EIGRP. Because with the previous videos I used EIGRP Classic. So I'm making it a little bit more complicated now. So hopefully you can follow along. But I'm using this named mode. You now have to do address family, IPv4, unicast, and then autonomous system 25. I know it's a lot, but once you've done it a few times, I wouldn't worry too much. It'll probably stick like glue. Okay, so now we're inside of this. Now we can specify. Sorry, no we can't. Not quite yet. There's still a little bit more. So you can see there's no option for redistribute in here. What we actually have to go into is topology base. So it's topology base, and now the redistribute command is available to us. So there's a fair bit you got to put in if you want to start configuring when you're using the EIGRP names. And remembering, this isn't even it. We've still got the extra steps with metric afterwards. So let's do what we did before. Start alphabetically. We'll start with BGP. So I'm going to redistribute BGP, autonomous system 100. But we still have to specify metric for all of these. So if I don't specify anything, so I'm redistributing into EIGRP now. I haven't specified metric, so if I go to router 4, where I'm expecting the BGP routes will not come in. So if I do a show IP route, sure enough, we don't see any of the BGP networks coming through. So we do still have to specify that metric keyword. Again, I've gone through this in a previous video where we redistributed between EIGRP and OSPF. So check out that if you're a little bit confused. But again, I'm going to do something slightly different. I could just do metric here and then start specifying the metric. But I'm actually going to do it a little different. So I'll do a question mark here. We have a few options like we always do. But one of the options that we can put in is this one, default metric. So I can set the default metric here, and that will then apply to all of the other protocols that I redistribute in. So I only have to set this once, rather than every single time. Let's make our lives a hell of a lot easier by doing that. So default, metric, and now it just follows along the same way that we've done this in the past. So I'm just going to do 1 million. The delay is 1, and then 255, then 1, then 1500, same as we've done before. Now that I've set that default metric, that applies to everything that's redistributed in. So now I can simply just go to router 4, let's refresh this, and instantly it comes up. So now we're getting that BGP and the RIP networks. Fantastic. And now I should be able to continue along like I did with the other protocols and just do redistribute. What's next in the list? Next in the list would be EIGRP, but that's what we're currently redistributing into. So OSPF. OSPF, press this ID 1, enter. No metric required. Refresh this, if I can click into it properly. And look at that. They all come through straight away. Easy. And then I'll do the same thing. I'll do redistribute, the last one being static, and that's it. No metric required. Refresh, and we're getting the static routes, including the default static routes. So there's nothing extra you have to do here on EIGRP to get them in. But we are missing the 10.0.1.0 because we haven't included connected. So redistribute, connected, and then we're done. So router 4, it's picked up everything. Fantastic. Alright, so the last thing that we need to do is redistribute into static. Now, you might be asking, how the hell do you do that? How do you redistribute into static? Well, the great question, because you don't really. It's static routing it's not like a routing protocol that's like running on the device. You just set manual IP routes. That's what static routing is. And so what I've done is configured a static route that goes up to router 8. So for everything else, it's going to go straight up there. Now the issue is if I haven't configured it properly on both of these devices, I'm not going to be able to get all the traffic all the way through. So hint, I haven't. If I go to router 9 and do show IP route, we can see it knows how to get to what's directly connected, and it's got a static routes to 10.0.1.0, but it's not going to be able to reach EIGRP, for example, because it doesn't have any route to get there. 172.16.0.4, that one's just going to fail. It doesn't have a route in its routing table. But if I put in a static route, hopefully will resolve the issue. So IP route 0000 and then 0000, and now I've got to specify how do I get to everything. I'm just going to specify the next hop on router 8, 10.0.0.8. So now if I get out of this, just exit, sorry, show IP route. Oops, accidentally right clicked. We can see I now have this default static route that just points to the next hop to go to everything. And then on router 8, do I have one open? No, I don't have one open for router 8. I'll open up a console session. We'll verify that it knows the same thing. Thankfully it does. It's got a static route that doesn't point back to router 9, it points down to router 3. So now if I go to router 9 and I run that ping to EIGRP, success. Cool. So, hypothetically, that should be it. We should have pretty much configured everything to get all networks to talk to each other. Now, we could do things a little bit differently. For example, on router 3, with the redistribution into EIGRP, is what we're currently doing. Instead of doing that default metric, we could instead do a route map. So we can, there's many different ways to do this, and it can get a hell of a lot more complicated. Start throwing in like OSPF version 3 with IPv6 and configuring route maps on every single redistribution. Let me just show you. So if I did redistribute OSPF 1, see one of the options here is route map. I could do route map and then specify route map, and then you have to look to the route map and see what I specify in there, because in the route map that's when you can specify the metric, and it would still achieve the same outcome. I've made it a little bit simpler for everyone here by not doing so much detail, but there is still a fair bit to get through with this lab. So obviously feel free to go back and watch it as many times as you need, but I would suggest going through this sort of stuff yourself. I'm going to provide the config files for the default setup before I did the redistribution in the description so that you can download them. You may just have to adjust for like device names, interface names, because mine is called E for Ethernet. So you might have to make some adjustments for yourself, but yeah, feel free to use those, and then you just have to configure the redistribution to get that all working. Now let's just confirm before we close off that it actually does work. So I'll go to router 1, and we'll go to, from router 1, we'll go to router 9, 7, and 4, and make sure that traffic can go not just to each device, but can get back, which is verified with ICMP traffic. So let's start with router 9. Ping 10.0.0.9. Please, please, yes. Alright, next one. Ping 20.0.2.7. Yes. Alright, last one will be EIGRP 172.16. Ping 172.16.0.4. Success. Excellent. So router 1 can ping to 9, to 7, and to 4. Noting that to go through to 7, it's going into RIP, which then redistributes its routes into BGP, which redistributes its routes into OSPF area 0, which then redistributes into a different OSPF area, which is 51, all the way through to router 7, and then it comes back. So there's a fair bit going on, but we've successfully configured route redistribution between all these protocols. Now, this doesn't cover absolutely everything. I haven't covered off on like ISIS, for example, and I haven't covered off on redistribution from RIP into EIGRP directly, or vice versa. To configure and go through every possible route redistribution with every protocol would just take way too long, or I'd have to cover it at a very high level without going into detail, which isn't what I want to do. If I'm teaching this stuff, I want to be able to go into enough detail so that you can properly understand what's going on. So if you are curious about some of the other things, like maybe redistributing BGP into ISIS, just go into a lab and give it a crack. That's pretty much how I've gone through a lot of this. I just go into it and just start typing redistribute, seeing if the option's there, and then press enter and just see if it works, and if it doesn't, troubleshoot. And this is how you learn. Alright, but aside from that, I hope you enjoyed. Feel free to drop down some comments if you've got some further questions. This is a fairly complicated lab, as I've said plenty of times already, so feel free to ask questions if you've got them. Otherwise, I do appreciate the time that you've put in to reach this far in the video, and hopefully I'll see you in the next one.